Hello, my name is Russ Baker. Today we're going to study what determinants are and how determinants in the form of Cramer's rule can be used to solve linear systems. A determinant of a matrix, whether it's 2 by 2 or any other square matrix, is a real number associated with a matrix in such a way that in a 2 by 2 matrix you take the product of the diagonals and subtract them. So for a 2 by 2 matrix, the process of finding the associated determinant is fairly quick. To find the value of the determinant of this matrix, we would simply multiply -1 times 3 and subtract -2 times 5, which is -10, giving us -3 plus 10, or 7. The solution of determinants for larger matrices is much more difficult and involved. We will solve one 3 by 3 by a solution technique which is called minors. After that, we'll be using our graphing calculator. Here's an equation that can be solved that involves determinants. This matrix has an x value in it, and out front you see the letters DET. So this is the determinant of this 3 by 3 matrix is equal to 5. Our problem is to find out what value of x would allow the determinant's value to be equal to 5. In order to do that, we have several steps to follow. The first step to do a solution by something called minors is to choose a row or column that you'd like to start with. A row or a column. If there is a row or column with some zeros in it, that's even better, and we want it to be as simple as possible. Therefore, I'm going to choose this third column to do my minors. Each entry in our chosen column will have its own minor. Each of those minors has to be multiplied by either +1 or -1 according to an array of signs. For a 3 by 3 matrix, the array of signs looks like this. Since we're looking at the third column, we want the first to be +1, the second to be multiplied by -1, and the third to be multiplied by +1 again. It's therefore possible for us to go ahead, and I'll show you how to evaluate by minors. Here is our determinant written out again with our x in the bottom. We've chosen to use this third column, and so we'll start with this upper value of 0. The array of signs says to multiply that term by +1. Then we multiply by the entry itself, and then we multiply by the determinant of a smaller, in this case 2 by 2 value, which we can find by taking the entry we're looking at and crossing out that row and that column, leaving us with the determinant of 2, 0, -3, x. Now we'll move on to our second term. Our second term is going to start from this entry in our chosen column, and we'll add the array of signs value of -1 times the entry itself, 1, times the determinant of found from the matrix by crossing out the middle column, middle row, and the last column again, leaving us with 4, 3, -3, and x. Now we'll go on and do the third version. The third term can be found by looking at the third entry in our chosen column and the array of signs will tell us that that's a positive 1. The entry itself is negative 1, and the determinant is found by crossing out those rows and columns, and we end up with 4, 3, 2, 0. All of that is still equal to 5. What remains to be done is to actually evaluate each of the determinants and see what kind of equation we'll get. This first term here is 0 times the determinant. That's going to be 0, so that term drops out. This determinant is 4x minus negative 9, which is 4x plus 9, times negative 1. Negative 1 times 4x plus 9. Remember, it's positive because it's 3 times negative 3. 3 times negative 3 is negative 9, but it's subtracted. All right? Then the next one, 4 times 0 is 0, minus 3 times 2 is 6. Negative 6 times negative 1 is positive 6, equals 5. We'll continue with our equation system, looking at removing those parentheses. Negative 4x minus 9 plus 6 equals 5. We'll combine the terms there and get negative 4x minus 3 equals 5. Negative 4x equals 8, adding 3 to both sides. And so x is equal to negative 2. When x is equal to negative 2, the original determinant equation will be true. Now you can try solving a determinant by minors as well. Expand this determinant to find the equation of a line through 2, 3, and negative 1, 4. This is an interesting application of determinants. You notice that if we're going to try and find an equation of a line through 2, 3, and negative 1, 4, notice how the determinant matrix is created. X and y variables with 1 in the third column. 2, 3, the coordinates of the point, and 1 in the third column. Negative 1, 4, the coordinates of the other point, and 1 in the third column. We want this determinant to equal 0. So turn off the tape, solve the determinant by minors to find the equation of the line passing through 2, 3, and negative 1, 4. When you're done, turn the tape back on. How did you do? Do you know what the equation of the line is? Let's see. This determinant matrix could be done the same way as our previous problem. We can choose any row or column, but once again, this third column seems to be the easiest because it's all ones. So let's proceed with this one by minors. The value from the array of signs is plus 1. The entry itself is 1, and the determinant is found by crossing out the top row, the last column, and giving us 2, 3, negative 1, 4. Then we do negative 1 for the value of the array of signs, times 1, times the determinant formed by crossing out the middle row in the last column. That would give us x, y, and negative 1, 4. And then finally we have the array of signs value is positive times positive 1 will just give us 1 times the determinant of bottom row and last column. Crossed out would give you x, y, 2, 3, and all that equal to 0. Now let's do some evaluation and find out just what that is. This first determinant is 8 minus negative 3. 8 minus negative 3. The second one is, this is a negative, and the determinant is 4x minus negative y, or plus y. And the third one is positive 1 times with 3x minus 2y. Well, we're almost there. 8 minus negative 3 is 11, minus 4x minus y plus 3x minus 2y equals 0. Let's combine some terms. We have negative 4x plus 3x, that's negative x. We have negative y minus 2y is negative 3y, and we still have this 11 out here. So we get 11 minus x minus 3y equals 0. If you'd like to multiply through by negative 1 and rearrange the 11, you get x plus 3y minus 11 equals 0, which is the general form of an equation. Probably one of the most important applications of determinants is the use of something called Cramer's rule, which can be used to solve linear systems. Let me explain to you just what Cramer's rule is. If there is a system, our system is 3 by 3, but it happens to work for any size system, given the coefficients a1, b1, c1, and the constant d1 in each of 3 different equations with subscripts just telling us which row they come, which equation they come from with variables x, y, and z, we can put together a series of determinants where the x value is something called the x determinant divided by the determinant of coefficients in each of the x, y, and z. Now let me explain to you that first of all, the d values here, without any subscript, are the determinants formed from the matrix using the coefficients a, b, c1, a2, ab, c2, and a, b, c3. That's called the matrix of coefficients, and the determinant from the matrix of coefficients is our d. To find the d sub x, d sub y, and d sub z, we do this. We take to find dx, we take out the a, or coefficients of x, and replace them with the constants. For dy, we take out the b values, the coefficients of y, and replace them with the constants. And similarly with dz. Let's see how this will set up then in a specific example. If this is our original system, 2x minus y plus 4z equals negative 2, 3x plus 2y minus z equals negative 3, and x plus 4y plus 2z equals 17, we can first write the determinant of the coefficients. The determinant of coefficients would be 2 minus 1, 4, 3, 2, negative 1, 1, 4, 2. Now we could go ahead and make substitutions to find the remaining d sub x. D sub x is the determinant where we take out the first column, 2, 3, 1, and replace it with negative 2, negative 3, 17. That is, we replaced it with these constant values from our system. The other parts to the determinant matrix remain unchanged. The dy will replace the center row in our determinant matrix. Negative 1 will become negative 2, then negative 3, and then 17 down the center column. The first column will remain the same. Third column remain the same. Then we get to dz. Now we take out the 4, the last column, and replace it with negative 2, negative 3, 17. And the first two columns remain the same. 2, 3, 1, negative 1, 2, 4. Fortunately, we can do all of these calculations once we know what determinants to use. We can find the values of these determinants using our graphing calculator. Let's go there and see how this all works. We turn on our calculator, and we'll see that if we go to the matrix value, I've already entered several matrices in here so that we can do this particular problem. Let's take a look at matrix A first. Do you recognize what that matrix is? It's the matrix of coefficients: 2, -1, 4, 3, 2, -1, and 1, 4, 2. What we want to do is we want to, according to Cramer's rule, put that in the denominator of an fraction and use dx in the top, and then we'll know what the x value of our problem is. Let's go back to our matrix and look at matrix B, and notice that I've taken the first row, column 2, 3, 1, the first column 2, 3, 1, and replaced it with -2, -3, 17. Consequently, I have got dx in my B matrix value. Now let's clear this, because what we want to do is we want to take the determinant value. We can find the determinant of a matrix by pushing matrix and then math, and you see the first choice is det. So we can put determinant, and then we can push matrix again, and we want our numerator value to be b, because that's our d sub x, 2. Then we want to close our parentheses and divide that by the determinant of matrix, math, determinant, matrix A, because we want that to be our denominator, and then hit enter. That simple calculation tells us that the solution to our system is x equals -3. Likewise, we can go back, we could press second entry, go back up to here, and change that B to matrix C, which I put in as my D sub y, and find out that y equals 4. Repeating again, and changing that to matrix D, I find out that I have 2. That's the solution to my system by the Cramer's rule and using the graphing calculator to help us do the mathematics. X is -3, y is 4, and z is 2. In order to use our calculator effectively, you need to be able to know how to enter the matrices and find the determinant value. Let's summarize the skills that you need to know about determinants. You need to be able to calculate the value of a 2x2 determinant by hand. You need to be able to calculate the value of a 3x3 determinant using minors. We used an application problem in which we solved determinant equations by solving by minors. We also discussed Cramer's rule as a way to solve linear systems of equations. Use your graphing calculator to evaluate a determinant and apply Cramer's rule for large systems. Practice these skills until you understand and can solve systems using determinants.